Okay, so in this last little piece, we're going to talk about parallel and perpendicular lines and how you can write the equations to something that's either parallel or perpendicular. So here are the two really big takeaway points. So parallel lines, remember parallel lines look something like this. They run right next to each other and they never intersect. They never cross. And the reason that they never intersect and never cross is because they have the exact same slope. So you'd say these lines are parallel if they have the same slope. So that's super important. So if you're ever asked to draw a parallel line or to come up with the equation of a parallel line, you would know that those two lines would have the exact same slope. All right? Next is perpendicular. And the definition of perpendicular lines, if we draw a line that looks something like this, perpendicular line meets it in right angles. So like these would all be right angles, all four of these pieces right here. So that's what it means to be perpendicular kind of geometrically. Their slopes, we call them opposite reciprocals. So opposite means you switch the sign. So you can see like one has a positive slope, one has a negative slope, and then reciprocals means you flip the fraction. So for example, let's say that one of them is 3/2. The opposite reciprocal of that would be negative, and then you flip to 2/3. So those two would be slopes that are opposite reciprocals. They would be slopes that would end up perpendicular. Okay, so with either parallel or perpendicular, you could be asked a question like this. You want to write an equation that passes through a certain point and is perpendicular to this equation. So here's what people have difficulty with this type of problem. They see the negative 5x plus 1, and they know that the slope is important, and that's true because the slope is important, but they also think for some reason that the y-intercept is important, and it's not. Like this line is parallel to this line no matter what their y-intercepts are. And this line is perpendicular to this line no matter what their y-intercepts are. So this plus 1 has literally completely nothing to do with our problem. We care about the slope. Okay, so if this slope is negative 5, that means the slope of our line, the slope that we're talking about, should be opposite and reciprocal of negative 5. So it should be positive because this is negative, and the reciprocal of 5 is 1/5. So again, this slope compared to this slope, they are opposite reciprocals of each other. We do not care about this y-intercept. Not at all. All right, so we've got the slope, and then we have a point right here. So that is our x1, y1, and we're going to put it into point slope form. So here it is. We've got y minus y1 equals the slope, and then x minus x1. I would have that memorized as soon as you can too. So let's plug everything in. So y minus our y value, which is negative 2, equals the slope, which we know is 1/5 because it's perpendicular to this line. And then x minus the x value, which is right here, it's 3. So all you have to do is clean that up. You just need to get it into slope-intercept form. So this is y plus 2 equals, and I can distribute that 1/5, multiply it by the x, and then 1/5 times negative 3 is negative 3/5. Okay, last thing to do is subtract the 2 from both sides. We'll clean that up a little bit. So I get the y by itself equals, I have 1/5 x, and then here I need to worry about subtracting this. So they don't have the same denominator, and we need to have the same denominator. So I'm going to multiply this by 5/5. Okay, so think of this as 2/1. So what I'm trying to do is take a negative 3/5 and then subtract 10/5. So that's like our little side problem that we're working on right now. So negative 3/5 minus 10/5. So now that they have the same denominator, I can combine the numerators. So it's a negative 13/5. So that would be your final equation. It's perpendicular to this. Negative 5 is opposite reciprocal to 1/5. And then if you plug this point in, you could see it would make the solution true. All right, that's it.